The content of this slide is about the definition of land surveying, types of surveying, how many types of jobs you can do with the equipment, things like that. We will identify what is plane surveying, what is geodetic surveying. Firstly, what is land surveying? Surveying is the measurement. So the land surveying is the measurement of the land features. So you will determine the positions of the points on or near the Earth's surface. And broadly, the surveying is the methods that you're using and how you collect the information or the data, and then you process the information and you present the result, like the maps or reports, calculations about the Earth and the environment. So, why do we need the land surveying? So land surveying is important, so it gives you the direction once you want to travel. So you have the map, that's an example. Can you give more example of the land surveying? So you have the property management, you need to know the property boundaries, of course, and we see that we also need to manage our environment as well. So this is some of the example of the land surveying. So other things, we determine the size, the shape of the Earth's surface. Types of surveying. So we want to classify different groups of applications. So you can use land surveying to do the measurement of the height on a vertical plane. So we call the leveling. You determine the ground floor elevation, you determine the building's elevation. So you're going to use this feature, which is leveling. The contour survey. You will need the contour survey because you want to know the features of the topography of the land. You know the low point, the high point, where you want to build a road or you want to build a new building. You need to know whether you have to do grading. It means you have to cut or fill, and that is the earthwork you have to do to make sure that you have a flat level where you can build the road or the building. Topographical survey. It will include the contour survey anyway, but it is extended to other features. You will produce a map where you will show all of the features like the hills, valleys, streams, rivers, forests. It's like a tourist map, but it will include other features showing the high point, low point of the terrain. The long section survey. So we call the long section, so that is a route or an alignment along a road normally. So you will do a survey along a new road or for an existing road to know about the elevation of the road, and then you can do the design. The cross-section survey. So normally if you have a road, then you will need to do the two features. So you see that you will have a road. For example, I'm going from point A to point B, so I will need to do the elevations along this road. So we call the long section survey. For example, every 100 or every 50 meters, you determine the elevation, and then you know the high point, low point of the road over here. But we also need to know the elevation of points at each position here. So you will need to know not only one point at the center line of the road, but we need to do the survey widely. So you need to extend the survey area to the two sides of the road over here. You will then have a cross section. This is the cross sections along this road. If you measure the elevations along this cross section, we call the cross section survey. Another type, you have the control traverse over here. So simply you will build a network. So you have a map, and then you will need to find some points. You have to determine the exact position of the points here on the Earth's surface. And once you know the position of this point, you can use this as the reference point, for example, to build a house. If you have a building over here, something like this, for example, if you build a structure over here, and then you need to have some of the reference points here. So to build a network of this reference point is a control survey, or to determine a number of control points here for the other surveying work. The setting out, as we mentioned before, you have a design, and now you want to bring the design to the construction. So you will need to determine the length of the building, the width of the building, for example. You need to know the height of the building, and all of these things you are going to do on site. So then you will need to use the instruments to determine exactly the length, the width, the height of the building, and you need to relate these points to control points here to make sure that you have built the buildings here in the right position. I'll tell you an example. If you have a road over here and we need to build a house over here, but instead of setting out the points on the left side of the road here, so the surveyor, they make a mistake. They determine the house here on the right side of the road. So then they have to demolish this one and rebuild another one on the left. We then have the cadastral survey. Cadastral surveys establish property lines and property corner markers. So basically, to manage the land. So how you build a house, then you see that they will need to determine the right boundary of the property. So determine the boundaries of the properties, that is the cadastral survey in general. So now you can see some example of different types of surveying. So here you have the contours survey, you have the topographical survey over here to show the elevation in terms of the contours and all of the other features of the land. Here I can see the topographical survey and also the long section over here. I have a road over here and I have a number of cross sections over here to do the surveying. This is the plan of the properties. So we see the road and we see the properties over here with the boundaries. So we need to do these cadastral survey to manage the land area for each of the owners over here. Once you want to do the setting out, you see that you need to have the control points. So these reference points will have the coordinates. And from these coordinates, you can then link your buildings to these coordinates. For example, you know that the distance from each corner of the buildings here to the reference point, and you know the angle, for example, of this line compared to this line. So then you can determine the right position of this building. Make sure that you don't build it in another position. Other example over here. So we have long section survey over here. So we can call profile as well. So you need to have a road, go from where to where, and then you can then determine the elevation of different points here on the road. Then you can draw the profile. Now we know that at this position, wow, it's quite low, and here it's a very high, 300 meters difference. You have to go down and go up if you don't want to make any adjustment to this existing road. Another example for the cross section. So you can see over here we have a cross section. You have the natural ground here. So we have the dashed line here as the natural ground. And you want to build a road. So you see that when you want to build this road, then you will need to know the existing elevation of this road. And if you build this road lower than the existing over here, you have some cuts over here. If your road is higher than the natural ground, you need to fill it up over here to get to the required elevation. So we are going to know the elevation of the existing ground by doing the cross-section survey. Now, consider the plane and geodetic surveying concepts. Plane surveying. Plane means flat. So you see that we assume that our Earth's surface is flat. We know the actual Earth's surface is not ideally flat. It's a curve, and we have the shape of the Earth is the ellipse. So when you do the survey on the surface like this, if we want to measure the distance from A to B, so the length here is the length of the curve. But when we measure the length here, we measure the length as a horizontal line. So the length of this horizontal line will be slightly different from the actual length of the curve. But we will not considering the errors between these measurements. So we say that we consider that the errors is negligible. So the reference base, it means the horizontal plane here, is assumed to be flat and horizontal. Remember that this survey is only for a small area, but it is big enough for all of our construction projects. In the next part, the geodetic survey, on the other hand, we see that our Earth here is an ellipse. And we see that if we measure the length from A to B, that's the length of the horizontal line. But then you see that the actual length over here from A to B is a curve. So it will be slightly longer than the length from A to B over here as a line. So that's why we need to consider these effects when you measure the distance in a large area for a very long distance like this. Otherwise, you will have quite big error. So read this one. Surveys cover a large part of the Earth's surface. The spherical shape of the Earth has to be taken into account for the errors of the measurement. So it's important to have the geodetic surveys to determine the reference point, to know the exact positions of the points on the Earth's surface. That's all for today.